Lesson 8. Functions and equivalent algebraic expressions. When working with algebra, it is very useful to know how to simplify expressions. So it's always useful to know how to simplify expressions. Simplifying can also be used to verify if two expressions are equivalent. We can use simplifying to check if two expressions are equivalent. Let us look at an example. Verify algebraically if the following functions are equivalent. F of x equals 2x squared minus x minus 1, and g of x equals 2 times x minus 1 squared plus 3x minus 3. So we're going to check if these two are equivalent. Since f of x is already simplified, simplify g of x. We note that this is already simplified. We can't simplify this perfect square trinomial anymore. Sorry, not perfect square trinomial, but we can't simplify this trinomial anymore. We can simplify this by squaring this and simplifying. So we're going to simplify g of x. Then you will be able to see if the two functions are equivalent. So then we're going to be able to see if they are equivalent. So we simplify g of x. 2x minus 1 squared plus 3x minus 3. X minus 1 squared is x squared minus 2x plus 1. So we get a perfect square trinomial. Then we simplify. Plus 3x minus 3, we bring this down. Then we expand the 2. We expand. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 1 is 2. And we bring down plus 3x minus 3. Then we simplify. 2x squared minus 4x plus 3x is negative x. Plus 2 minus 3 is negative 1. We get 2x squared minus x minus 1, which is the same as this, 2x squared minus x minus 1. Therefore, the algebraic functions 2f of x equals 2x squared minus x minus 1, and g of x equals 2 times x minus 1 squared plus 3x minus 3 are equivalent. So therefore, these two are equivalent. The method of simplifying algebraic expressions is very simple, and simplifying rational expressions is done in the same way. So we simplify rational expressions in the same way we simplify algebraic expressions. A rational expression is the quotient of two polynomials. So a rational expression is always a quotient or the division of two polynomials. Basically, it is a fraction with a polynomial numerator and a polynomial denominator. So it's a fraction with a polynomial in the numerator and the denominator. Remember, a fraction is a division operation. So keep that in mind, that a fraction is always a division. Remember, you cannot divide by 0. So when you simplify, you must make note of this. So division by 0 is impossible. We learned that a while ago. So when you simplify, you have to make note that you can't divide by 0. This is known as a restriction. Example, x is not equal to 3. So this is a sample restriction. X is not equal to 3. And it states that a certain variable cannot have a certain value for that function. So a restriction states that a certain variable x cannot have a certain value 3 for that function, as an example. If it did, the denominator would be 0, and that is impossible. So if it did have that value, if x was 3, the denominator would be 0, and that's impossible. We can't have the denominator being 0. So the function has an undefined value at that point. So the value of the function at this value, x equals 3, is undefined. You must check all the variables in the denominator to see if you will need to write a restriction. So you have to check all the variables in the denominator to see if you are going to have to write a restriction. The restriction must be written beside your answer at the end. So you have to write your restriction at the end beside your answer. Let's go through an example. Simplify the following expression and state any restrictions. So we simplify x squared plus 10x plus 21 divided by x plus 3. The first step is to break up any trinomials that are present by factoring. So first we break up any trinomials that are present by factoring. We have a trinomial present in the numerator. That means we can factor the numerator. If that's possible, if that's the case. And we can see here that we can factor the numerator, because we have 21 as a constant term, and 7 times 3 is 21, and 7 plus 3 is 10, and the coefficient of the x term is 10. So we can use 7 and 3. We can factor this using 3 and 7 as our constant terms for the binomials that we will use. The first step is to break up any trinomials that are present by factoring. So that's always the first step. There is a trinomial in the numerator, as we noted, which can be factored. Once it is factored, we will be able to simplify the expression. So once we factor this, we can simplify the expression. Remember, always simplify any polynomials which can be factored in the first step. So the first step is always to simplify any polynomials which can be factored. So again, factor the trinomial in the numerator. We have x squared plus 10x plus 21 is the trinomial in the numerator. We factor it. We get 3 and 7, as we said, as the constant terms of our binomials. So x plus 3 equals times x plus 7 divided by x plus 3. We bring down the x plus 3 division. Now simplify by crossing out like terms in the numerator and denominator. Cross out. So we simplify by crossing out like terms in the numerator and denominator. We cross out x plus 3 since it is found in the numerator and the denominator. So because x plus 3 is in the numerator and the denominator, we cross it out, which leaves us with x plus 7. So we bring that down, equals x plus 7. Now we must state any restrictions on the variable, or any values that the variable cannot have to satisfy the original equation. So we have to state all restrictions on the variable, or any values that the variables cannot take in order to satisfy the original equation. To do this, look at all the expressions that make up your denominators in your calculations. So to do this, look at all the expressions in your denominators. In this case, we had only one denominator throughout our calculations. So we had only one denominator throughout all our calculations, found in the first step, x plus 3. So in the first step, we had only one expression that was in the denominator, x plus 3. We know that the expression x plus 3 cannot equal 0. We know that x plus 3 cannot have a value of 0. We can set up an inequality to solve for x, and solve for x to determine the restriction on the variable x. So we can set up an inequality and solve for x to determine what the restriction is on the variable x. So x plus 3 cannot equal to 0. We isolate x by bringing 3 to the other side. So x cannot be equal to negative 3. Therefore, the restriction is x cannot be equal to negative 3. The final simplified expression with the restriction is x plus 7, x cannot be equal to negative 3. Remember, always write all restrictions on all variables, if applicable, after the simplified expression. Remember, always write all restrictions on all variables. So you have to remember to write all restrictions on all variables that apply after the simplified expression, or after the answer. And that's all for Lesson 8, Functions and Equivalent Algebraic Expressions. Stay tuned for Lesson 9, Working with Rational Expressions. Also, if you enjoyed our lesson, be sure to like and subscribe, and leave a comment down below. Thank you.